Hello, everyone. Today we are going to continue with our isosceles and equilateral triangles, but we're going to see how we can use these in proofs. So if we look at this problem, we know that AE is equal to ED. That's my given. And we also know that AB is equal to CD. It's my other given. And what I want to prove is that triangle AEC is congruent to triangle DEB. So we have a fill in the blank proof here. So that means I've done most of it for you. You just got to fill in what's missing. So our first reason says if two sides of a triangle are congruent, then the angles opposite are congruent. So that's our isosceles triangle there. Well, we knew that AE was congruent to ED. So the angles that are across from those are angle D and angle A. Then it's saying BC is equal to BC. Well, whenever it's something equal to itself, it's reflexive. Then what did I do here? I added. So that's addition. So now we need to look. What do I get when I add AB and BC? So AB and BC together give me AC. That's congruent to what do I get when I add CD and BC? CD and BC added together give me BD. That's substitution. Now we need to figure out why we know those triangles are congruent. So I'm going to erase a lot of my stuff here. And I want to only write down what I said in this problem. So I know that AE is congruent to ED, and I know that AC is congruent to BD. I'm going to make my one triangle blue with what I know, my other triangle green with what I know. And then I know this angle is equal to this angle. So that's side, angle, side, because I know the two sides and the angle in between. Next proof. So here, I know that angle P is congruent to angle T. And actually, let me do two different colors there. Blue congruent to green. And I know PX is congruent to TY. So there's TY, there's PX. And I know that RX is congruent to RY. Oops. So first thing I have is I used reflexive. Well, I'm looking for Q is congruent to S. So really the triangles I want are going to be this, because I want Q is congruent to S. So S is up here, which is part of this triangle. And then I want Q, which is part of this triangle, this blue triangle. So really, where I have overlap is XY. So I know XY is congruent to XY. Then I added, and I got PY. Well, what am I going to add to get PY? Well, what I add to get PY is PX and XY is equal to TY plus XY. And then once I add those, that's substitution. So now I have those two sides down there equal. And I already had an angle. So now they're looking at SXT. So I'm going to erase some of this so I can see where SXT is. So we're talking about SXT is congruent to QYP. So I'm looking at this angle and this angle. Well, to know why those are congruent, I have to remember back to my givens, which said that Rx is congruent to Ry. So that means this little triangle here is isosceles. So this is the isosceles triangle theorem. And now what I have, again, I'm going to erase because my drawing gets complicated, but I said P is congruent to T. I had PY is congruent to TY. And then I just said this little angle is congruent to this little angle. So that's angle, side, angle, because they all touch. And then once I know the triangles are congruent, I can get the parts by CPCTC. So that's the end of today's video. If you have questions, let me know. Tomorrow in class, you're going to work on doing, I think, 3 more proofs. 3 more proofs. So if you have any questions, please let me know.